See, in this topic, we are going to be discussing about the pulse modulation. We are going to be discussing about the pulse modulation. What is the pulse modulation, sir? Pulse modulation is an example for discrete modulation. Pulse modulation is an example for discrete modulation. Means that is not analog. In analog communication, if you say, all that is called analog. But here, this is called discrete modulation. Here, instead of a analog sine wave, we are using here a discrete pulse train. A discrete pulse train. Even though carrier is a discrete pulse train, this modulation scheme we are using for both continuous as well as for discrete information. If you see in the olden days, previous days, modulation, transmission, reception, reproduction of information all are in a analog form. But here we are using the carrier is a discrete pulse train. So even though information we are using is analog, but here what we are receiving is a samples of information. So not we are receiving the information, a samples of information. From the samples of information, we are reconstructing our original information. So these modulation schemes are having an inbuilt characteristic of sampling error. Inbuilt characteristics of sampling error. Sampling error also called, students, Nyquist error. Sampling error also called, students, Nyquist error. Are you getting my point or not? Follow. How this sampling error or Nyquist error can be reduced? By taking more number of samples, we can reduce the sampling error or Nyquist rate. By taking more number of samples. How many samples we have to take? How many samples we have to take is given by what? Is given by sampling theorem. Sampling theorem will give you the minimum number of samples to be taken to reconstruct the original information from the samples. So who is giving? Sampling theorem is giving. So what is the sampling theorem statement? Sampling theorem is saying that a continuous time signal band limited to, for example, a continuous time signal band limited to FMHS. My meaning of FM is message signal frequency. A continuous time signal band limited to FMHS is converted into a discrete time signal and without any information loss is converted into discrete time signal without any information loss, provided that the sampling rate Fs, provided that the sampling rate Fs greater than or equal to 2 samples per second. What is the Fs, sir? Sampling rate. And what is sampling interval Ts is less than or equal to 1 by 2 Opposite conditions now. Units are here, sample per second. Here the units are second. Sampling rate, sampling interval. If you see this one, there are three conditions will come to students. Fs greater than 2 Fs equal to 2 Fs less than 2 The first one is called what, student? The first one is called oversampling. This is called critical sampling. This is called undersampling. There are three samplings. Anyhow, what is the practically preferred one? Please tell me. The practically preferred one is the, yes, oversampling. Why, sir? What is the thing there? Or if I tell you a simple example from about the sampling theorem, you can see. For example, you can take the drawing book of a children's. You can take the drawing book of a children's. In that book, there are some dots they will give you. If you smoothly connect those dots, then you will get a image. Are you getting my point? For example, originally they given 100 dots. Now I am drawing that figure in two ways. First case is 100 dots I am increasing to 200 and I am drawing the figure. Second case, 100 dots I am decreasing to 20 and I am drawing the figure. In those two cases, where is the figure clarity will be good? Please tell me. Yeah, obviously in the first case, because we are increasing the dots to 200. The meaning is dots means the samples. Take more samples, the clarity will be good. So the preferred sampling rate is oversampling. Critical sampling or ideal sampling means we need a ideal low pass filter in the reconstruction side. Practically not possible. So practically preferred one is sir over sampling. I will tell you another example also. For example, if you take the BSNL, in the previous it is called DOT, Department of Telecommunication. So what we are sending here voice signals. Voice means 300 to 3.4 kilo. Even if I take the highest frequency, so 2 times 3.4, it is 6.8. But what is practically we are using in DOT or in BSNL? We are practically using FS value is 8 kilo. Are you getting my point or not? So, the practically preferred one over sampling. Now here, what is the importance of sampling theorem is, the sampling theorem importance is, students, any continuous time signal we can represent by 2 samples in 1 second. It's the most important thing of a sampling theorem, even though we never losing any information. Are you getting my point? Yeah. And coming to this pulse modulation, what is the advantages of pulse modulation? What is the drawbacks of pulse modulation? Let's briefly see. What is the advantage of pulse modulation? First advantage is, student, PT is small. Why sir? Why PT is small? Because in analog schemes, continuously we are sending. So continuously power is needed. But here we are sending sample, sample, sample. Are you getting my point? So the power is going to be saved. Second advantage is, students, this is a natural provision to TDM, time division multiplexing. We cannot go for TDM with analog modulation schemes. With pulse modulation schemes, we can go. Third thing is, students, try to understand this point. The amplifiers means continuous time devices, switches means discrete, means some devices handle and capable of, some devices handle and capable of is handling the high power when they use it as a switches rather than amplifiers. Some devices will handle with a larger power when they use it as a switches rather than amplifier. Are you getting my point or not? Means here you can see micro switches, thousands of kilowatts of power. Normal amplifiers, small. Amplifiers means continuous time. Switches means discrete, on and off, on and off. So if you are using the devices like that, you can handle a larger amount of power. Coming to the drawbacks, duration is small, time is small. Then obviously what's the opposite one? Frequency is more. The meaning is they need a large bandwidth. All 3 points you will get in the notes. Don't bother about that. So you will get the drawback. First drawback is large bandwidth. What is the second thing is, I already told in the starting itself, these are having a natural problem of sampling error or Nyquist error. Now, for example, If Fs value is less than 2 FM, then we are having a problem called aliasing effect. Means the frequency components will be interfered to each other, reconstruction not possible. Are you getting my point? Third point is, are you getting my point? Here, if you are increasing the holding time, if holding time is increasing, you will also get the aperture effect. Holding time increases, you will get the aperture effect. These are the drawbacks of the pulse modulation. Advantages: PT small, TDM handle the larger power. Drawbacks: larger bandwidth, sampling error, Nyquist error, as well as aperture effect, as well as aliasing effect. Clear? In this topic, we are going to be discussing about the classification of pulse modulation. Coming to the classification of pulse modulation, this is classified into two types. One is called pulse analog and another one is called pulse digital. Are you getting my point? What is the difference here? In both cases, carrier is pulse train only, but here information is analog, but here information is digital. This is also called true digital modulation also we can call. Are you getting my point? In both cases, carrier is pulse train only, but in pulse analog, information is analog, here information is digital. This is also called true digital modulation. Coming to this pulse analog modulation, this pulse analog modulation is classified into two types. One is called, students, pulse amplitude. A means amplitude. One is pulse amplitude modulation. Another one is called pulse time modulation, where T called time, pulse time modulation. This pulse time modulation is categorized into two types. One is called pulse width modulation. Another one is called pulse position modulation. Here W is called width, pulse width modulation. Here middle P is called position. And remaining pulse modulation, that is common. This pulse width modulation is also called, students, pulse length modulation, also called pulse duration modulation. L means length, D means duration. Pulse length modulation are also called pulse duration modulation. Another names. Are you getting my point or not? So this is about the total pulse analog modulation schemes. Coming to the pulse digital modulation schemes, what we are having the pulse digital modulation schemes are: the first one, pulse code modulation. C means code. Pulse code modulation, as well as we are having differential. D means differential. Remaining as usual. Differential pulse code modulation. PM means pulse code modulation. C means code. PM means pulse modulation common. So differential pulse code modulation. Next we are also having DM. D means delta. M means modulation common. Delta modulation. And we are also having adaptive delta modulation. A means adaptive, and variable step size. Here a constant step size, here variable step size. So total we are having here 4 modulation schemes in pulse digital. Those are pulse code modulation, differential pulse code modulation, as well as delta modulation, as well as adaptive delta modulation. Are you getting my point or not? Now here, what we are happening in these modulation schemes, if you want to clearly know, these modulation schemes are nothing but not a modulation schemes. These schemes are nothing but conversion of continuous time signal into digital. Continuous time signal into digital. Here, discrete. Are you getting my point? Directly, we can also use them for transmission through cables. These two will be through the cable only. If you want to transmit through free space, now we have to make for these either ASK or FSK or PSK. Preferable one is phase shift keying. Are you getting? That is the best suitable one for digital communication. In ESC examination, the number of times the objective questions are coming. How they are coming, sir? They are coming as which of the following is pulse analog scheme? Which of the following is pulse digital scheme? Like that they are asking. Try to remember the classification in the pulse modulation. Clear? Yeah. Let's see what is the carrier we are using, students. We are using the carrier is pulse train we are using. Let's take the pulse train. This is the pulse train we are using. So coming to this one, let's mark this is some T1. What is those values? I will tell you. This is T2. What is T1, sir? T1 is called pulse width or also called pulse duration. Width or duration. What is T2, sir? T2 is called pulse interval. T2 is called, sir, pulse interval. T equal to T1 plus T2. That is called pulse period. That is called pulse period. Where frequency equal to 1 by T. This is called pulse repetition rate or pulse frequency also you can call. Pulse frequency. What is the unit, sir? Cycles per second, or you can also write pulses per second also. Are you getting my point? Yeah. Next, coming to here, what is this? That is called pulse amplitude. That is called pulse amplitude. And this rising one, that is called leading edge. This is called leading edge. And this is falling. This itself is called trailing edge. Are you getting? This is leading edge, that is trailing edge. Clear? Next. What is the duty cycle? Duty cycle is called T1 by T. That is nothing but T1 by T1 plus T2 if you want a percentage into 100. So pulse duration by the total pulse period itself is called duty cycle. So these basic points try to remember: pulse width, pulse interval, leading edge, trailing edge. This is a pulse amplitude. What is called a duty cycle. Clear? Now we are going to be discussing about each and every modulation scheme. Clear?